sphere of radius r, which means r is already given, so this will remain constant. My radius of the sphere will be constant. फिर वॉल्यूम ऑफ द लार्जेस्ट कोन, जहां जहां पे भी मैक्सिमम मिनिमम लार्जेस्ट स्मॉलेस्ट ऐसा यूज किया, दैट वुड बिकम अवर फंक्शन. So let the radius of the base of the cone is r. Small r लिखेंगे because capital R is already used. Let the height of the cone is h. Okay. This is 90 degree. क्या क्या वैल्यू मुझे दिए? The radius of the cone means this value is constant and equals to r. This value is also constant and equals to r. ठीक है, जैसे उधर रेडियस है, here also we can construct a radius r. Suppose we are substituting इतना जो portion है from this point to this point, suppose the distance is x. Supposition हमने किया. Then we can convert the height in terms of x as h equals to, from the geometry of figure we can say it is r plus x. Similarly, small r will be equals to, or small r square equals to, using Pythagoras theorem we can say capital R square minus क्या होगा x square. ठीक है, तो दोनों वेरिएबल को एक सिंगल वेरिएबल में ला दिया. Let this be our equation 1. Okay, so radius of sphere was constant, identity used थी, and we have converted both height and radius of the cone in terms of x. Next step, किसको function बनाना है? Volume. तो volume of the cone will be 1 by 3 pi r square h. So instead of r and h, now we can substitute. This is equals to pi by 3 constant. Instead of r square, we can write capital R square minus x square. So instead of h, we can write capital R plus x. Product form में नहीं रखेंगे, will always convert into simplified form. So we'll expand the bracket. Pi by 3 will remain constant. Inside the bracket, capital R square into capital R will become r cube. Then plus r square into x minus r into x square minus x cube. बोलो 2 whole square.
x square by r square.
Okay. Done. This is simplified form. So we can now say let f of x is equals to our v volume. चलो, therefore first step भक्ति issue कर issue differentiation f dash x equals to, बोलो differentiation pi by 3 constant bracket, differentiation of r cube will be 0. Then r square constant into differentiation of x is 1 minus r constant differentiation of x square is 2x minus differentiation of x cube is 3x square. Okay, done, which is equals to 5 by 3 capital R square minus 2r into x minus 3x square. Okay, done. Let this be our equation number 2. Let f dash h is equals to 0. Therefore we can say, देखो pi by 3 चला जाएगा. Directly now we can say 3x square plus 2rx minus r square equals to 0. Say 3x square then plus 3rx minus Rx minus R square equals to 0. We'll take R common from the second last two terms and 3x common from the first two terms. Therefore, 3x common, inside the bracket we'll get x plus R. In second last two terms we'll take minus R common, x plus R. Okay. So now we can say 3x minus R into x plus R equals to 0. Therefore, because x is dimension, it can take value only equals to R by 3. It cannot take minus R because dimensions are always positive. Equation, let f double dash of x equals to 0 minus 2R minus 6x. Because x is positive and all the terms are negative, irrespective of the value of x, double differentiation will be less than 0. Or f of x is maximum. F of x is maximum. At which value x is equals to R by 3. Okay. So we can say now volume equals to V equals to pi by 3 R square minus value of x is R by 3. So whole square will be R square by 9 into R plus value of x is R by 3. Okay. Which is equals to pi by 3 into, after taking LCM we'll get 8 R square by 9 into, again after taking LCM we'll get 4R by 3, which is equals to 8 into 4 will be 32, 9 3s are 27, 3s are 81, 5 R cube. Okay, this is our volume of cone. Volume of sphere will be 4 by 3 pi R cube. By taking the ratio of both, V upon Vs will become equals to 327, 4 8 are 8 by 27, pi r cube will get cancelled out. Hence we can say volume of cone is nothing but 8 by 27 of volume of sphere, which is proved. So that right circular cone means normal cone of least curved surface. Least word is used, which means the curved surface will become our function. Given volume, given word is used, which means volume will become our constant. V is constant. It has an altitude. We have to prove for the least curved surface and given volume, altitude means h is equal to root 2 times the radius. Okay, this we have to prove. Let the radius of the cone is r. Let the height of the cone will be h. Okay, slant height is L. Now given volume, it is given that volume is constant. So V is equal to, bolo, pi by 3 into R square into H. Let this be equation 1. Curved surface area of cylinder is, or sorry, cone will be pi into R into L. Instead of L, we can write under root of H square plus R square. Because we have root, we'll take square on both sides and we'll get pi square R square inside the bracket H square plus R square. We'll expand the bracket and we'll get okay. अभी मत करो एक्सपांड, डायरेक्टली क्या कर सकते हैं अपने y square r square as it is instead of h square. Now we can write 3v upon pi r square whole square plus r square. So this function now converted into single variable, that is capital R. Pi square r square into, inside the bracket we will get 9v square upon pi r raised to 4
So pi का इधर भी है
plus r square. Bolo.
pi square.
So final a square will be equals to
9 bar
9
b by r whole square.
b square by r square.
तो b by r.
क्यों v by r करना है अलग अलग, क्योंकि वेरिएबल को तो डिफरेंशिएट करना है. प्लस
pi square r
I square into r raised to 4. So let f of x is equals to, or f of r is equals to s square. Bolo. F is taking first derivative. So f dash r equals to, so we'll get minus 18 v square upon r raised to 3 plus pi square is constant. R raised to 4 differentiation will be 4r cube. So it will be 4 pi square into r cube. This is our differentiation. Let this be equation 3. Let f dash r equals to 0. Therefore, we can say 18 v square upon r cube equals to 4 pi square into r cube, which means r raised to 6 is equals to 9 v square upon 2 pi square.
इसका डबल डेरिवेटिव.
Therefore, we can say r is nothing but equals to 6th root of 9 v square upon minus 18 v square will be constant. Differentiation of 1 by r cube will be equals to minus 3 upon r raised to 4 plus 4 pi square is constant. Differentiation of r cube is 3r square. Hence double differentiation is 18 3 54 v square upon r raised to 4 plus 4 3 12 pi square r raised to 2. R is positive, both the terms are positive, overall value will be greater than 0. Therefore, we can say f of r is minimum at which value? At r equals to
9
6th root of 9 v square upon 2 pi square. From equation 1, we can say v square equals to pi square by 9 r raised to 4 into h square. We have done square of equation 1 because in equation 4 we have the value related to v square. Now from equation 4 we can substitute the value of v square, which will be
r is to 6 pi square
2 pi square upon 9 r raised to 6 is equals to pi square upon 9 r raised to 4 into h square. चलो, I square upon 9 will get cancelled out. R raised to 4 will get cancelled out and will get R square. So finally we'll get H square is equals to 2 times of R square. Taking the root both the sides, H becomes equals to root 2 times of R, which proves our question. Maximum volume, maximum word is used, so for volume will become our function. Given slant height is given, which means value of L is constant. We have to prove the angle, semi-vertical angle is equals to tan inverse 1 by 2 or tan inverse root 2. Let the radius of the cone is equals to R. Let the height of the cone is equals to H. Let the slant height of the cone is equals to L. This angle, which is formed between the height and slant height, is known as semi-vertical angle alpha. From the geometry of figure, we can say L square is equals to R square plus H square. This will give us the value of, since slant height is constant, this relation will give us the relation between two variables R as well as H. Equation 1. Volume of the cone equals to pi by 3 R square H. So pi by 3 constant, instead of R square from equation 1 we can substitute L square minus H square into H. Okay, making the function in terms of H will be convenient. Expanding the bracket, we'll get pi by 3 constant, inside the bracket L square into H minus H cube. કશું જ નહીં, સાઇન થીટા કોસ લાવવાનું જ નહીં. દર્પણમાં એવું આપ્યું છે, ઇઝી વેલ્યુ અવેલેબલ હોય વર્ઝન તો એ કરવું જોઈએ. ચલો, ડન. સો લેટ f of h is equals to our v. डन भाई. चलो नेक्स्ट स्टेप, आगे क्या करेंगे अंश, क्या करना है? Differentiation. So we'll find f dash of h. बोलो अंश, differentiation. Pi by 3 constant. Differentiation L square is constant. Differentiation of h is 1 minus 3h square. Okay. Then let f dash of h is equals to 0. Therefore, क्या बनाए बोलो? L square equals to 3 times of h square. Therefore, h is equals to L upon root 3. Equation यहाँ पे 2 to 3. F double dash of h should be equals to, बोलो differentiation, pi by 3 will be constant, instead of differentiation of h square will be 0, minus 3 constant, differentiation of h square is 2h. So value will be minus of 6 into h. H is positive. Because of minus 6, overall term will become negative. So irrespective of the value of h, f double dash is less than 0. So we can say f of h will have value which is maximum at h is equals to L by root 3. So we'll get tan alpha equals to opposite, that is R upon h. Now h we already know it is L by root 3. Value of R we can find from equation number 1. So we can say from 1 R square is equals to
L square minus
L square minus H square, which is nothing but L square by 3. So from 1 and we can say 4. Like from 1 and 3, इसको कोई जरूरत नहीं. From 1 and 3 we can say R square is nothing but equals to 2L square by 3, which means R is nothing but equals to root 2 by 3 of L. Now taking the ratio, tan alpha will be equals to, instead of R now we can write root 2 by 3 of L. Instead of H we can write L by root 3. L and by root 3 will get cancelled out. Final condition is tan of alpha is equals to root 2, or we can say alpha is equals to tan inverse of root 2. Our answer.